In this lecture, let's have a look at Python operators. Python operators can be divided broadly into arithmetic, string, relational, logical, bitwise, and assignment operators. Arithmetic operators perform arithmetic operations on numerical values. Most commonly used ones are plus, minus, star, slash for addition, subtraction, multiplication, and division. However, there are two types of division. One that gives you a fractional values, which is like 22 by 7, gives you 3.1428, etc. There is another one where you are not interested in the fractional values, you're only interested in the integer part of the division. And this is achieved by using a double slash. For example, 22 double slash 7 will give you 3. We also have an exponent operator, which is equivalent of x raised to the power of y. In this example, 2 star star 3 means 2 raised to the power of 3, which is equivalent of 8. We also have a modulus operator that gives the remainder after division. For example, 25 modulus 7 will give you 4. The operator plus and star can also be used with strings, but they have a different meaning. For example, if you're using plus symbol with two strings, it's called concatenation, which results into joining of two strings. Vinod plus Kumar will become Vinod Kumar as one single string. Star, on the other hand, is used for repeating a string. If you are using Vinod times 3, you're going to get Vinod, Vinod, Vinod as a single string. This can be used for creating a line where I can choose a character of my choice multiplied by 50 or 80 depending on how big the line you want. For example, I can say here print in single quotes a minus times 80 will give you a line that is 80 characters length. Or I can use a different symbol like this and then I get a different line. Or I can use a combination of two of them and then reduce this by 40 and now I get a line of this style. Relational operators can compare the values of two operands and then give you true or false as the resultant value. Less than symbol is used for comparing whether a value 1 is less than the value 2 or not. In this case, 10 less than 12, which is equivalent to true. Whereas less than or equals to can be used to check whether or not the first value is less than the second value or is it equals to the second value. In this case, 12 less than or equal to 12 gives you true. 12 less than 12 would have given false. Similarly, we have greater than, equals to. We also have a double equals, which is used for comparing two values, whether they are same or not. And also we have not equals to that checks the opposite of the above. These relational operators can also be used with strings, where the Unicode values of characters of the strings will be used for comparison. If I check Vinod less than Vineet, you'll see you get false. The reason for this is this operator now checks the Unicode value of V with V, since they are same, I with I, which is the same, N with N, it is same. Now it's going to check the Unicode value of O with Unicode value of E. Now to find the Unicode value, you can use the ORD function, and that's going to tell you what are the Unicode values of O and E, which is 111 and 101. Since 111 less than 101 is false, you get the result as false. However, if I type Vinod less than Vinuta, now you'll see that you're going to get true, mainly because for the first three letters, the Unicode values are same, they are skipped. But when it comes to O and U, the Unicode value of O is less than Unicode value of U. So we can check the same by typing ORD of O and ORD of U. You'll see that you're going to get 111 and 117. Since 111 less than 117 is true, it's going to result that into true here. Logical operators can be used for combining more than one condition. Each logical operator can be used with two conditions simultaneously. For example, 10 less than 12 is one condition, 10 less than 8 is another condition. 10 less than 12 results into true, whereas 10 less than 8 results into false. True and false is going to be false. False and true is also false. False and false is obviously false. So the only way a condition becomes true is when both the condition are true here. Similarly, if you're using OR operator, the moment the first condition is true, the second condition is never checked at all, because any one condition must pass, and if the first condition is true, it will never bother to check the second condition. Whereas if the first condition is failed, then it's going to check the second condition. If the second condition also fails, then the result is false. Otherwise, it is going to be true. In this case, 12 less than or equal to 12 is true, because of which it doesn't even check the second condition at all. The NOT operator can be used for negating the result of a condition. For example, in this case, 12 greater than 12 is false. NOT of false becomes true. Python also supports bitwise operators, though the practicality of these operators are very less. The operator double less than symbol represents what's called left shift. Basically, the bits will be shifted by the number of bits that you mention over here. For example, we have 12 left shift operator and then 2. So we want to shift the bits of this 12 by 2 bits and then calculate the result. Take a look at this example. 12 in binary format is represented with these 8 zeros and ones. And then when you say 12 left shift 2, so we basically want to make room for 2 more bits on the right side, because we're going to shift the bits on the left. As you can see that the bits have been moved towards the left, making room for these 2 cells. Now these 2 cells will always be inserted with zeros, and hence now the overall byte consists of 00110000, bringing that result into 48. Similarly, if you're trying to do a right shift operator, here is what happens. The byte consists of 8 bits with 00001100 representing 12. The moment you say 12 right shift operator 2, you want to shift all the bits by 2. So that means the leading zeros will be omitted. They are pushed out of the byte, making room on the left side. And these will be inserted with zeros again, making the whole bytes as 00000011. Now if you convert that binary number into a decimal, it becomes 3. Ampersand and R represents the binary and binary OR. For example, 12 and 13 results into 12, 12 or 13 results into 13. To understand the same, let's have a look at this one. Consider 2 numbers 151 and 137, 2 arbitrary numbers, and their binary equivalent of the same. Now, if you are trying to do an AND operator between these, the bits in the same index will be combined with the AND operator. So 1 and 1 will become 1, 1 and 0, or 0 and 1, they all become zeros. So effectively, you can see now that 1 and 1 is 1, and then all of these are going to be converted into zeros, and here is 1 and 1, so the total result will be 1 followed by 0 0 0 0 0 0 and 1. If you convert that binary into decimal, you're going to get 129. Similarly, if you want to do an OR operation between these, the bitwise OR operator now takes the bits in the same index and then converts that into an OR result. So 1 or 1 is 1, 1 or 0 is also 1, 1 or 0, 0 or 1, they all are becoming 1s. 0 or 0 and 0 or 0 become 0. So the result will now look like this, where wherever there is a 1, it becomes 1, irrespective of the other 0. But in case if there is 0, it's going to check the next one and then say it is 1, so it's going to result into 1. So the final result would be 1 0 0 1 1 1 1 1. If you convert this binary into decimal, you're going to get 159. Python supports shorthand operators for assignments. As you can see here, each one of these operators are equivalent of its lengthier format. For example, a plus equals to 10 can be written as a equals to a plus 10, but this is a short form notation of this lengthier notation. At this point in time, if you're coming from C, C++, Java or C Sharp, it is important to know that there is no plus plus or minus minus operators. So if you want to increment a value of a variable by 1, we may have to say a plus equals to 1 instead of a plus plus. Similarly, a minus equals to 1 is equivalent of a minus minus in other languages.